Hello everyone, I am Rishika Verma from IIPS DAVV and here I am with the presentation on Project Quality Management. Project Quality Management is a vital aspect of any project. The International Organization of Standardization defines quality as degree to which a set of inherent characteristics fulfill requirements. Many people joke about the poor quality of IT products. People seem to accept system being down occasionally or needing to reboot their systems. So quality is very important in many IT projects. Experts define quality based on conformance to requirements and fitness for use. Project quality management ensures that the project will satisfy the needs for which it was undertaken. Project quality management is broken down into three main processes that are quality planning, quality assurance, and quality control. Planning quality management. In this, we identify which quality standards are relevant to the project and how to satisfy them. A metric is a standard for measurement. Performing quality assurance. In this process, we periodically evaluate overall project performance to ensure that the project will satisfy the relevant quality standards. Performing quality control. In this, we monitor the specific project results to ensure that they comply with the relevant quality standards. Furthermore, while planning the quality of a project, we begin with identify the quality required by your customer or stakeholder. Then, we make sure that the process by which you manage that quality is acceptable to the customer. In next quality assurance phase, we have a system in place, like a process checklist or a project audit, to ensure that the quality of your deliverables align with customer or stakeholders' requirement. While evaluating the quality of a project, we monitor quality through every phase of the project and have metrics to make sure quality standards are being met. If it isn't meeting expectations, we adjust to set the quality back on track. This picture shows the three processes get executing in different project management process group with the output that it gives in different phases. There are 5 groups in the project management and in the 3 that are planning, executing, and monitoring and controlling, the 3 processes that are quality management, quality assurance, and performing quality control executed respectively in the 3 groups. The output of the planning quality management has quality management plan, process improvement plan, project document updates, etc. In the executing phase, the outputs from the quality assurance are change request, project management plan update, asset updates, project document updates, etc. In the monitoring and controlling group, the process of performing quality control outputs us with quality control measurements, validating changes, change request, project management plan updates, etc. And this phase is executed from the starting of the project phase till the finish phase. Now, there are 7 basic tools of quality that help in performing quality control, and that are cause and effect diagrams, Pareto charts, flow charts, check sheets, scatter plots, control charts, or histograms. Starting with the cause and effect diagram. This is also known as fishbone or Ishikawa diagram. This diagram traces complaints about quality problems back to the responsible production operations. They help you to find the root cause of the problem and can also use the 5 why techniques where you repeat the asked question why to find out the layers of symptoms that can lead to find the root cause of the problem in the system. The basic effect and cause diagram place the effect at one end. The causes feeding into it are then identical. We are brainstorming by working backwards along this spines or vertebrae. As in this diagram, in which we define the problems a user can face in a system. We have defined the four phases or four divisions of a problem. Like the problem can be of the system hardware, user hardware, software, or can be of the training part. And next, in the from the use of arrows, we define that what the problem can be. Like in the training phase, the problem can be the user can be able to reset the password. User keeps the forgetting password. As in the user's hardware phase, the problem can be there is not enough memory in the user system, or the processor is very slow to execute the project. So this is the fishbone or Ishikawa diagram. Now next, coming to the Pareto charts. This is a bar graph that shows which factors are more significant. This is just like a histogram that helps you to identify and prioritize problem areas. The Pareto analysis is also called as 80-20 rule, meaning that 80% of the problems are often due to 20% of the causes. The combination of bar and line graph here depicts individual values in decreasing order using bars, as you can see in the diagram, while the cumulative total is represented by the line. The goal of the Pareto chart is to highlight the relative importance of the variety of parameters, allowing you to identify and focus your efforts on factors with the biggest impact on specific part of process or the system. Now the third one is flowcharts. Flowcharts are most commonly used to document organizational structures and process flows, making them ideal for identifying bottlenecks and unnecessary steps in your process or system. Mapping out your current process can help you to more effectively point out which activity can be completed when and by whom, and how the process flow from one task to another, and also which steps can be eliminated to catalyze your process to complete your project fast. Flowcharts are graphic displays of the logic and flow of processes that help you to analyze the problem occur and how the process can be improved. As in the diagram shown, the flow chart of a password and username validation is shown as start, and then we take the username and password from the user. We check the validity. If it is valid, then we log into the system, and no, then we display an error message. And this is the basic representation of a problem flowchart. The next is check sheets. Check sheets can be used to collect qualitative and quantitative data. They can be called as tally sheets. It is used to collect and analyze data. A check sheet collects data in form of check or tally marks that indicate how many times a particular value has occurred, allowing you to quickly zero in on defects or errors within or process or product, and even causes of the specific defects. So this is the basic example shown in here diagram, and this information might be useful in improving the process for handling complaints. And this we have defined from the calls, reason of the calls from Monday to Friday, and there is a column with total of this, and we have shown the wrong numbers, information request calls from the boss using the tally marks, as these bars are used in tally sheets. So this is the way we describe check sheets. The next is scatter plots. Scatter plot is used to depict relationship between two variables, which is ideal for quality assurance professionals trying to identify cause and effect relationship, with dependent values on diagram y-axis and independent value on x-axis. Each dot represents a common intersection point. When joined, these dots can occur highlight relationship between two variables. And also, the stronger the correlation, the stronger will be the relationship between the variables. The scatter diagram can prove useful as quality control tool when used to define relationship between quality defects and possible causes such as environmental activity and other variables. The closer data points are to a diagonal line, the more closely to variables are the related. As I said, the stronger the correlation, the stronger will be the relationship, as you can see in this diagram. And this diagram is between the price and quality of a product, and this shows how scattered and closely related these factors are. The next is control, also known as run charts. These are used for graphical display of data that illustrates results of process over time. Control charts use a central line to depict an average or mean, as well as an upper and lower line to depict upper and lower limits based on historical data. You can use the quality charts and the 7 rule to look for the pattern in the data. So this is basically used for the pattern detection of the data in our project. The 7-run rule states that if the 7 data points in a row are all below the mean, above the mean, or are in increasing or decreasing order, then the processes needs to be examined for non-random problems. As in this diagram, we can see that the mean line is on the 12 inches and the points shown shows the graph, and this 2 stars we can see between the 5 to 10 time dimension, and on the 20th time dimension this denotes the violation of 7-run rule, as the 7 points get in the same line below the mean. Using a control chart can save your organization time and money by predicting process performance, particularly in the time of what your customer or organization aspects in your final product. Now, the last one are histograms. This is a bar graph of distribution of variables. The histograms can be held to represent frequency distribution of data clearly and concisely amongst different groups of a sample, allowing you to quickly and easily identify areas of improvement within your project or process with a structure similar to a bar graph. Each bar within a histogram represents a group, while the height of the bar represents the frequency of data within that group. Histograms are particularly helpful when breaking down the frequency of your data into categories such as age, days of week, physical measurements, or any other category that can be listed in chronological or numerical order. As in this diagram, you can see the height of the bar shows the frequency of data within a particular group, and width of them shows the group. So this is the representation of histograms. So that's all about the 7 rules of quality control, and that's it. Thank you.